What we're going to do now is we're going to jump over to the Advanced HMI side to connect up their software with the tags that we've just been creating. First thing we need to do is close out of vBuilder, and the reason we need to do that is because Advanced HMI is going to use the same COM port that vBuilder uses to talk. And you can get around this if you wanted to by using one of our PLCs with an RS-232 port. In that case, you would connect the RS-232 to a RS-232 to USB converter and then plug that into your PC. And you could, in that case, communicate with vBuilder over the built-in USB port and then Advanced HMI over the RS-232 port. So you could communicate with both at the same time. That would be fine. But in this case, we're just going to use the same port. So something that's going to be important here is we're going to use Device Manager. Here we go. If you're not familiar with getting to Device Manager, you would go to in the Windows search bar, which is often just to the right of the Windows button at the bottom left of your Windows, and you could type in Device Manager. If you can't find it there, you should be able to find it inside of your control panel. So what we're looking for here is if you're using the built-in USB port on the PLC, you'd find it under Ports, COM, and LPT. You'll find Velocio COM, and the thing we're concerned with is what number it is. In this case, it's a 3. If you were to be using one of our RS-232 ports with a RS-232 to USB converter, you'd look under, I believe it's serial ports, you'd have to double check on that, but it would come up as whatever brand name of converter you're using in that case. But for us, this is a COM3. That's what we're going to be interested in. Okay, hopefully you have already watched the brief Advanced HMI Getting Started tutorial that's further up in this tutorial set. If you have, you know how to have downloaded Visual Studio as well as Advanced HMI, and you've unzipped their files. Now we're going to go into the solution, and we will take a look at it briefly here. You see it's got 4 things. You've got the Advanced HMI, that's the main project. And there's an Advanced HMI CS, that's the C# version of this. And you can switch between which one you're wanting to use right here. We're just going to use the default, the Visual Basic version, which is the top one. You got your controls and you got your drivers. So we'll jump to the main form, and here you're free to edit all this stuff. You can get rid of it, you can change background colors, whatever you feel like doing. I'll change background color here just because I can. We'll go with that, and we will then the next thing we need to do is we need to build the solution, and that's because you'll see right here we don't see our different controls, our Advanced HMI controls yet. After we do the build, they will appear. Okay, yep, there we are. So now we have our Advanced HMI, our drivers, and all the built-in controls. So these are going to be very handy. What we're going to use for the driver is the Modbus RTU COM, and we just place one of those on the screen, and then we go to Properties. And the thing you got to change here, in our case, is we need to change the COM1 to COM3. The rest of the data here can remain the same in our setup. If you're using the baud rate in particular, doesn't matter when we're over USB. If you're using RS-232, you'd be concerned with these other settings more. We will now go ahead and place a couple simple controls on the form. We'll use a basic indicator first, and this is the one that we're going to, here you see it right here. We're going to tie this to the to that address 1, the input switch or the input bit on our PLC that I said I had hooked up to a switch. So we're going to use color 2, which is something we specify right here. It'll be green when it's on, and the default color when it's off. And we need to give it the address that we're tying to it. So in the case of bits, the prefix is 0, and then it's 4 digits of the address, so 3 zeros and a 1 in this case. And we can go ahead and run that. Now you should be able to, hopefully the switches are near enough the microphone, you'll hear it. When I turn it on, it does that. When I turn it off, we can do it rapidly a couple times there. So you see it's tied in there. You're already off and running. We will now go ahead and add a button. And this one you won't be able to see as well. I'll just have to tell you what's going on. If we add a basic, let's see, basic button right here. We add this, and we set its click property to, again, a prefix of 0, and this one's address 2, so 3 zeros and a 2, and we run that. And I push the button, and the light on my PLC, the digital output, it comes on when I press it, and it goes off when I release it. So that acted as a momentary button, a momentary set, and you see you've got other types here. And again, there's quite a few properties you can change here, and there's different events you can handle. But I'm just trying to go through a couple of the most basic ones. Another useful tool chosen somewhat at random is we'll use one of the gauges. Okay, and I will change a couple of these. In our case, we're using a 12-bit number that's going to go from a maximum of 0 to the highest 12-bit number, which is 4095. You can see it doesn't display great with those particular numbers unless maybe I made it a little larger in this, which I think it would look probably quite nice if I made it big enough. But anyways, we have that, and we can now select the address value. So in this case, every non-bit data, it's going to start with a 4 and then the address, so 0001. You'll see that there's other prefixes we have to add for unsigned, for longs, which would be our I32s, and for floats. But anyways, we'll select that. We'll go ahead and run it. You'll see how easy this is. I'll pull it into view. I've got my knob. I will twist it. I'll lower it, and then I'll go, and I'll see if I can go about midway. There we go. And then we can go all the way to the end. And I'm sure there's a way to customize this quite a bit if you'd like. So there is that. The next thing we'll do is we will add a analog value display, and I'm intentionally going to cause, I'm going through this one because I know there's going to be a slight issue here, and I just want to show you how to get past it. It's not a big deal, but I just want you to be aware of it. So I'll make the font a bit larger to start with, and here we go. And the next thing you definitely want to do is add the value, and we'll go with the float, which will be the F4000 and 4002. However, we're going to run into a problem here. There we go. So we get this value. Property value is not valid. This doesn't have to do with it being a float. We could have used the same 4001 that we used over here. We would have gotten the same results. This has to do with apparently it's open source projects working in Visual Studio. It can create some minor problems, but I'll show you how to get past this. So what we can do is we can close out of here. We'll save our changes. We will clean the solution. I will jump out of Visual Studio, which won't take very long. I'll jump back into Visual Studio. I'll go back to my most recent project here. I will do a rebuild. So if you run into this is how you can quickly recover. It's going to play nicer this time, and we can now use our F4002. You see it took it that time, and for that minor effort, it's a pretty nice payoff. And you can see this is the floating point. So we use that F prefix, and sure enough, it's going to be the same value. You can see we're at 3270 something apparently looking at this gauge. So these are matching. Just we told the floating point to be 0.1 larger than the other number. So this is all working. That should get you off and running. I think you're going to find this a real helpful tool that you can use with very little basic knowledge, but then you can once you develop some programming skills, or perhaps you already have them, then I think you're going to be able to take advantage of it. It's real handy not having to start from scratch with the Modbus RTU.